Okay, so I'm going to go through specific heat capacity, as many people were absent yesterday. So our equation is Q equals mc delta T. Delta T just means that we subtract the final and the initial temperature. For all of this information, you can find on Google Classroom under the notes, but the notes don't have any of the math, so that's why I wanted to make a video. So this is our equation, Q equals mc delta T. So basically, specific heat capacity is the ability for just like a measure of how a material absorbs heat, and we're going to use it to solve some problems. So aluminum has a specific heat capacity of 0.902 joules per gram degree C. If you have 50 grams of aluminum and it rises from a temperature of 100 to 125, how much heat is required? Okay, so if we look here, this is our equation, Q equals mc delta T. So we're given the specific heat, which is 0.902 joules per gram degree Celsius. Here are all the units. If you want, that'll help you figure out what is in the problem. So this joules per gram degree Celsius is our C, our specific heat capacity. 50 grams, grams is our mass. T initial is 100, and T final is 125 because it's rising from 100 to 125 degrees Celsius. So your first step is to find your change in temperature, which is T final minus T initial. So we're basically just subtracting the final minus the initial temperature. So 125 minus 100, we got a 25 degrees Celsius. And then we can plug it into the equation. And we're solving for Q. Q is our unknown. Our heat is Q in joules. How much heat? That's Q. So we have Q equals my M, which is 50, times my specific heat is 0.902. And then temperature is 25, my change in temperature. And you can go ahead and multiply that out. And you get 1,127 joules. I'm going to round it to 3 significant figures, so 1,130 joules, because each of these, the least amount of significations, this one has 3, this one has 3, this one has 3, this one has 4, so you round to 3. And that's your answer. When 655 joules, that's our Q, is added to a sample of ethanol, its temperature rises from 18.2 to 32.8. This is our TI and our TF. What is the mass in grams of an ethanol sample if the specific heat capacity is 2.46 joules per gram degree Celsius? The joules per gram degree Celsius is C. I'll just write the units again. So C, the units are joules per grams degree Celsius. Q, it's in joules. M, it's in grams. And our temperatures are in degrees Celsius. So that can be a hint to how to figure out what variables you're looking for. So we have our TI is 18.2, TF is 32.8, Q is 655, and C is 2.46. We're solving for what is the mass? So our M. Here is our equation. And we're going to go ahead. Your first step is to solve for your change in temperature. So 32.8 minus 18.2. And we're going to do 6. And then we can plug in our equation. We have 655 is our Q. It's equal to mass, which we're solving for. 2.45 is our C. And our change in temperature is 14.6. So your first step is to multiply these guys right here. And we get 655 equals m times 35.77. Then you can divide by 35. And we get our mass to be 18. I'm going to round to 3 significant figures again, 18.3 grams. Okay, example 3, 19.22 joules. Joules, remember joules is our Q. So Q is 19.2. 15 grams of a substance, so that's our mass. From 45 degrees Celsius to 57. So our TI is 45, our TF is 57, and we're solving for C, the specific heat. We're going to use this equation. So we get 19.2 is equal to 15. First you have to subtract your T final minus T initial, so 57 minus 45, we get 12. Times C times 12, we're going to multiply our 15 times 12. We get 19.2 is equal to 180 C. You can divide by 180 on both sides. And you get 0.106 joules per grams degrees Celsius. Titanium has a specific heat capacity of 0.523. If you have 15 grams, so this is our C, this is our M, of titanium at an initial temperature of 30 and 6 joules of heat, that's our Q, what will the final temperature be? So we don't know our final temperature, but in order to find the final temperature, we need to find our change in temperature. So our Q is 6 joules, our TI is 30 degrees Celsius, our C is 0.523 joules per grams degrees Celsius, and our mass is 15 grams. So we're going to solve for this first, and then we can use our just change in temperature as T final minus T initial to solve for our final temperature. So we have 6 equals 15 times 0.523, and then our change in temperature. So 15 times 0.523, we get 7,845. Oh, nope, that is wrong. I multiplied it wrong. $7.845. And then we can divide by 7.845. So our change in temperature is 0.765. Then we take our change in temperature, and we have 0.765 is equal to T final minus our T initial is 30. To solve for T final, I add 30 on both sides. You get 30.765 degrees Celsius as your final answer. The rest are independent practice, so now you should be able to do the rest of the packet.